A very common source of confusion and consternation comes from differing the arithmetic average from the geometric average or average rate of return in the application. So I've gone to this website, slickcharts.com, to get S&P 500 returns. And you have to be very careful which S&P 500 returns you're referring to. Because notice it says total return, and then you have to figure out what are your start and end values for comparison. So here I'm using the start value of January 3rd for the year 2000 of the SPY adjusted close. And I'm using the end value for 2025 of 680. So the arithmetic average is just that. It's the average that you're used to. So to find for this in Excel, it's very simple. We just say equal sign average, and we're going to take this series and get that amount. This would be no different than if we added up all these values here and then divided by the total number of observations. And we can get the number of observations just by counting here. So we see there's 26 observations. So another way that we could do this, as we can see, is equal to sum of all of these values, and then just simply divide by the number of observations in the data set. We can change this to a percentage for comparable form. So how would you interpret this 9.69? Well, this is the expected value. If you were saying, what do I expect as a return in the coming year, it would be 9.69%. On a bell curve distribution, this would again be your mean, so it's the average. So it's that expected value. It's not necessarily what you're going to earn, but that's what you would expect to earn. So that's the interpretation of the arithmetic average. Again, it's just your expected value. It's that mean value in your bell curve distribution. The geometric average is a little bit different. This is taking into account compounded average growth rate. So you're saying if I started at 9137 and 25 years later, 26 years later, you end up at 2025, what rate of return would you have to multiply times that to get to that value? Okay, so there's a couple different ways you can solve for this. So the first one is we'll do 1 plus this amount. So really the compounded or the geometric average is just simply 1 plus our return for that period. We multiply them together and then take it to the power of 1 divided by the number of observations, so 1 divided by t. And so it's giving us the root of 26, all right? If we were going to do the last 3 years here, just to get over that period, we would simply say is equal to 1 plus this amount times 1 plus 2024 times 1 plus 2025. Next, what we need to do then is take that to the power of 1 divided by the number of observations, which would be 3, and then minus 1, and that's going to be our geometric average over that period. Over that same period, our arithmetic average would just simply be so they're pretty darn close in a short run period is what I want to point out. However, when you go to a longer period of time, you really need to differentiate between the arithmetic and the geometric. So I've already added 1 to each of these. And normally you would say, okay, is equal to this times this times this times, and that's just a big hemorrhoid. So the easier way to do it is to use the product function. And we're going to use the product function over that range there. And so this is just 1 times everything, but now what we also need to do is say, well, is equal to this amount to the power of 1 divided by the number of observations, 26. And then lastly, we want to subtract 1. And so we get approximately an 8.7% rate of return. So that's one way to solve for the geometric average. Another way is if we have prices, we can take our starting or ending price and divide it by our starting price. And so if we just did that alone, and then we minus 1, that's our percentage of increase. But what we're going to do first is we're going to take that to the power of 1 divided by 26, and then we're going to subtract 1. And so notice these two are darn close. It's basically a rounding error, and we can double check this or verify this amount. And the easy way to verify this is just to take our starting amount of 9137, multiply it times 1 plus our geometric average to the power of the number of years, 26. And you can see that we end up with 680.06, which is our ending value in 2025. So really, the geometric average here is pretty spot on. It's just a rounding error. This one's accurate why we have these starting and ending values. So 2 different ways to solve the same thing. So again, the arithmetic average here, that's the mean value, what you would expect to observe if somebody asked you, what's your expected rate of return next year? 9.69%. Of course, it'll be plus or minus that for how many ever standard deviations you're taking into account. But that's the expected or the mean in your bell curve distribution. The geometric average, on the other hand, is that's the average rate of return compounded year by year by year. So every year from the year 2000 through the year 2025, you had a compounded rate of return of 8%. So not too bad over that period of time. And notice we had 2 big downturns at 2000, 2008, and even the COVID time in there, or a little post-COVID. And still we ended up getting a pretty good rate of return over the long haul. So hopefully that it helps separate the two again. Expected value in your bell curve distribution, rate of return, compounded year after year, so compounded average growth rate.